For today's software engineering interview, we would like you to design an automatic SQL assessment platform such as HackerRank. We're going to keep things simple. We're going to use a React frontend and a Node.js backend to serve our web application. And for persistence, we're going to use a Postgres database to store our application data, things like user information and problem metadata. Our main goal is to execute SQL queries. We can do so by taking the SQL query string and execute it directly against our application database. And once we get the result, we can return it back into the frontend. And because every problem has a predefined dataset, these datasets need to be seeded into the application database as SQL tables for candidates to query during an assessment. But how are you going to ensure that users don't query data from other problems? And also, how do you support multiple dialects? You're right. Well, we can enforce data isolation by using row-level security. There's no way for us to support multiple dialects because we are locked into our application Postgres database. So instead, we're going to use containerization. Each time somebody wants to access a problem, we're going to spin up an isolated, short-lived container with an image of the chosen dialect. In this case, we support 5 different dialects, but this list is expandable. This enforces really good isolation because each sandbox is only seeded with data of the chosen problem. When users now want to execute SQL queries, we'll take the query string and execute it against the sandbox of their chosen dialect and problem. Doing it this way, users will only have access to the data of their chosen problem and nothing else. This allows us to support multiple dialects because we can easily spin up new containers with the different dialects but seeded with the same data. So how are you going to grade queries? We can't compare query strings directly because there are multiple ways to write queries to produce the same data. So instead, we're going to validate it by comparing result sets. When a user submits the query for grading, we'll execute it to produce a result set. We'll compare it directly against the answer set row by row, and if it matches exactly, we'll mark the query as correct. This allows for flexibility in how the candidate writes the query so long as the logic produces the right data. How do you ensure that candidates don't get stuck waiting for containers to spin up each time they access a new problem? We can introduce pool management. We keep a pool of warm containers ready to go in the background. Each time there is a new request, we check the in-memory map on the server for an existing container for a given problem and dialect. If the container exists, we grab a container from the cache and execute the SQL statement against it. If it doesn't, only then do we bear the cost of creating a new container from scratch.